Hi, this is Brandon Baines in the Math Department at Lipscomb University, here to talk with you today about linear inequalities. In this presentation, we'll learn how to determine if a given x value is a solution to an inequality, how to solve linear inequalities, and how to represent the solutions to linear inequalities. A linear inequality is a statement of inequality that involves a variable raised to the first power and constants. Examples include 3x plus 5 is less than 7x minus 9, 2 times a quantity x minus 1 is greater than 4, and 3x is greater than or equal to 0. So what is a solution to an inequality? Well, the solution to a linear inequality is a value of x that makes the inequality true. This is essentially the same definition as we discussed with solutions to equations in the previous presentation. For example, x equals 4 is a solution to the inequality x plus 5 is greater than 2, because when x is 4, we have the statement that 4 plus 5 is greater than 2. And that's a true statement. You might take a look at the inequality x plus 5 is greater than 2. You might think, what other x values would make that true? And it turns out that there are quite a few, right? If x is 0, then you have a true statement. And if x is 100, we have a true statement. And in fact, there are an infinite number of x values that make that inequality a true statement. And for that reason, whenever we solve an inequality, we have to represent those solutions visually. And so for linear inequalities, we do that on the number line. And we can either make our own number line and shade the number line, or we can use wolframalpha.com and plot our solutions there. Let's take a look. Is this a solution to the following inequality? We're looking at x equals 1/2, and we're looking at the inequality 10x minus 11 is less than or equal to x. Again, as we defined on the previous slide, if this is a solution, then when we let x be 1/2, then we should have a true statement. All right. When we let x be 1/2, then we have 10 times 1/2 minus 11 is less than or equal to 1/2. 10 times 1/2 is 5. 5 minus 11 is negative 6. So we have the statement negative 6 is less than or equal to 1/2. And that's a true statement. Therefore, x equals 1/2 is a solution. Again, it's one of many to this inequality. All right, how to solve an linear inequality? Well, we actually get to solve linear inequalities just like we solved linear equations in the previous presentation. There's just one exception to this, and it has to do with multiplying or dividing by a negative number when solving. And when we do that, it's important that we change the direction of the inequality. So if the inequality is a less than statement, it must change to greater than, and vice versa. To see why we do this, we might consider the statement 9 is less than 20, and consider that if we divide both sides of that inequality by -1, our left-hand side becomes -9, and our right-hand side becomes -20. Well, if we compare those two numbers, -9 and -20, you may think of that as owing someone $9 and owing someone $20. We would definitely conclude we would rather owe someone $9 than owe someone $20. So that is, you actually have more money, even though you still owe somebody in that scenario. You owe them less money, right? If you if you owe them 9 versus owing 20. So you would have more money, or that is negative 9 is actually a greater number than negative 20. And so we would have to write this statement negative 9 is greater than negative 20. All right, and again, once we solve these inequalities, we'll represent those on solutions on the number line, and we'll use Wolfram alpha for this. Consider the inequality 2x plus 5 is greater than x minus 1. Again, we'll solve this just like solving a linear equation. So we're going to subtract x on both sides so that we can get all of our x's on the same side. And again, the choice to subtract x is motivated here because x minus x would give us 0 x's on the right-hand side. We're left with the inequality x plus 5 is greater than negative 1. We'll subtract 5 on both sides, and that will result in x is greater than negative 6. And so that is our solution. Any x value greater than negative 6 will make this inequality true. To represent that solution, x is greater than negative 6, we'll go to wolframalpha.com, and we can type graph x is greater than negative 6 on the number line. We'll type in that whole phrase. This symbol, of course, is on your keyboard. The greater than symbol is on your keyboard. You can even say, just spell it out in words, greater than, and Wolfram Alpha will know what you're asking it to do. And so here we see on the number line, we have all of the numbers that are greater than negative 6 shaded. And you'll notice here this open circle. That is indicating that negative 6 is not actually included. Okay, notice our solution is x is greater than negative 6. That does not include equality to negative 6.